Welcome, ladies and gentlemen. I'm Linda Sandahl with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webcast, the Commercial Building Energy Alliance's High Performance Lighting for Parking Structure Specification, brought to you by the U.S. Department of Energy's Commercial Building Initiative. Today's speakers will provide an overview of the High Performance Parking Structure Lighting Performance Specification developed by members of the Department of Energy's Commercial Building Energy Alliances. We'll discuss lighting options to consider, review financial incentives, and highlight a parking structure lighting renovation that's underway at one of Cleveland Clinic's sites in Cleveland, Ohio. I'm happy to announce our speakers today, Michael Meyer of the Pacific Northwest National Laboratory and John D'Angelo of Cleveland Clinic. Michael Meyer has been with PNNL for about 4 years now. Prior to joining the lab, Michael worked as an architectural lighting designer in New York. And since joining PNNL, Michael has worked on a wide variety of lighting projects. Currently, he splits his time between 3 major programs: the Solid State Lighting Commercialization Program, Federal Appliance Standards, and the Commercial Building Energy Alliances. John D'Angelo is the Senior Director for Facilities, Construction, and Real Estate at Cleveland Clinic. This position gives him the opportunity to develop professionally through his responsibility over in-house and outsourced facility directors, managing a portfolio of 203 buildings at over 23 million square feet in 10 Northeast Ohio counties, 2 Southeast Florida counties, and Las Vegas. John also chairs the U.S. Department of Energy's Hospital Energy Alliance and participates in several local and state energy committees and working groups. Once again, please ask questions via the computer, and we will answer those at the end of the presentations. We should have about 30 minutes for questions. Michael, I'll turn it over to you.
Thanks, Linda. Moving into the agenda for today's presentation. So quickly we'll talk about, there'll be an introduction about the energy alliances and some basic information about energy usage in buildings. And then we'll spend a little time on estimates about parking structures, energy use, typical fixtures, design issues. Also discuss a review of the CBA specification. That'll be the center part of the presentation. There's other presentations that are archived on the Department of Energy website. If you want to really go in depth on the specification, this presentation is going to give some highlights of the specification, but we've done a number that have gone into great depth on them in case people are very interested in them. Then we'll also discuss a review of financial incentives. Those are always important because people always like a little help in doing stuff, and those are some listed there are some places where the financial incentives exist. And then finally, John D'Angelo will present an example in action in his use of the Cleveland Clinic. So that completes the introduction phase, and we'll move into the rest of the presentation. This is data from the Department of Energy, Energy Information Agency. The breakdown of energy use, the pie graph on the left shows you roughly that buildings use 40% of the energy. And then it breaks out the buildings by residential and commercial. And then if you look at the bottom of commercial, the single largest single use is lighting at 21% of commercial buildings. Of course, depending on your building type, that number is going to vary. Heating, HVAC, heating and cooling, when combined, often is the largest. But when you separate the two out, they are less than lighting usually. So it's good to know that lighting is such a large player in buildings and sometimes often overlooked. In the last couple of years, the Department of Energy has formed energy alliances. The 3 current energy alliances are listed here. There's a retailer energy alliance, the commercial real estate energy alliance, and a hospital energy alliance. The end goal of the energy alliances is to group similar organizations, whether they be retailers or, in John's case, be hospitals, healthcare entities, and then or commercial real estate. And commercial real estate is by far the most diverse, just because you could have something like a shopping mall or an office building, which are different, but they're still commercial real estate. The idea is to pool them together, share resources, concerns, knowledge, and develop projects. And ideally, the project would cut across one or multiple energy alliances, and they can pool buying power and other things to help bring energy efficient solutions to the Energy Alliance. We have developed an LED site lighting specification that came out of one of the Energy Alliances early on, and then there was a request for a parking structure specification, and that's what brings us here today. It has been out for a while, and this is just another presentation on the specification. The next part of the presentation will be on estimates about parking structures. I think it's always good to know some good information about the parking structures and how they operate and typical energy use to see what the potential is. So here's some quick facts. I was surprised when I came across this. 110 million spaces are estimated of parking structures across the United States. Now again, that's not structures itself, but that's collectively that there's about 110 million spaces. That number is used because you sometimes factor in number of fixtures per space, so that gives you at least an estimate of roughly how many fixtures you'll need or other type of things, other metrics. The fixture wattage for a parking structure, because of a low mounting height and some other issues, typically can be anywhere from 50 watts up to 200 watts. You sometimes go above 200 watts, but definitely the large bulk of input power for lighting fixtures tend to be in this range. Long daily operation, it's estimated that typical parking structures operate 18 hours per day. Obviously, there are many structures that operate much longer than that, but estimates that Department of Energy has done is 18 hours per day, which translates to just over 6,500 hours per year. And then energy use. So when you combine the hours and the wattage estimate, not that range, but they've actually, the way the Department of Energy has done some of these calculations, you get a pretty large number, 28.1 terawatt hours. Put in perspective, a terawatt hour, well, let's just think of power. So you have watts that we all know of, then the next unit up is kilowatts, then the next unit up is megawatts, then the next unit up is gigawatts, then the next unit up is terawatts. So it's a very large number. There's a lot of zeros, and I didn't write it up to make it easier. What else do we know about parking structures? Well, they're infrequent occupancies at times. This because you don't spend a lot of time there. You drive around, you find your spot, you get out, and you go into your building or the plaza that you're parking at for whatever reason. So so the people aren't spending great deals of time there, and as well as they're not continuously operated. They're operating related to the building or site that they're located at. So in some cases, you might have high use for seasonal if the parking structure is located near a mall, and then maybe low use on the weekends or on Sundays when the mall's closed. The two pictures on the right are examples that were taken. One is Old Orchard Mall that's in Skokie, Illinois. This is early, not too early in the morning, but it was early in the morning. Notice no one's there. The other one above is Tufts University. It's midday in the afternoon on a Saturday. Then the parking structure is rather empty as well. So the infrequent occupancy of the spaces and the low occupancy at times really allow for some great control savings, which we'll discuss in a second. Also, the image on the bottom really shows that daylight is prevalent there, and that, again, that's a great thing that you can use to save energy, is to either turn off or dim or reduce the output of a fixture in response to daylight. And the specification really tries to go after these additional control savings because the controls can mean so much more than just using more efficient equipment. Again, this is more information. The previous data that I showed and now this, it all came from Department of Energy estimate on niche lighting applications. While the report was focusing on LEDs, the background numbers are still the same regardless of what technology we're looking at. So those hours of use and terawatt hours all came from this report. What I like about this breakdown is it really breaks down all the different technology types and what we're seeing. So this is dated in 2011. You'll see, if you look, induction represents about 7% of installed equipment, high pressure sodium and metal halide, 23 and 15%. Fluorescent is pretty large, 45.9%. So we're seeing a lot of fluorescent, high number of fluorescent equipment installed. But that's typically because you need more fluorescent fixtures in a parking structure than you would of other technologies. And then a small potential of LED technology installed. And it's important to see that if you look at combining high pressure sodium and metal halide, that those two really add up to 48%, almost 50% of all structures are lighted by those two technologies. And the specification really tries to target those technologies because currently there are some options you can do, but the majority of HID sources have problems either being used with an occupancy sensor or being used with a dimmer, and so we're trying to target again the controls advantages of other technologies. Moving into the next slide. So this is a breakdown from a great book. If you ever want to read a lot about parking structures, the reference is at the bottom. It is a very long book. It is very thorough, though, at the same time, covering everything from construction to operation of parking structures. But the interesting thing here is that you think about it, utilities constitutes about $10 of your cost of a parking structure, or $50 per space. And as I mentioned, I said earlier, there's 110 million spaces in the United States. That number adds up quickly. And if you think also about most parking structures are not heated or cooled, so all of a sudden the utility costs is a lot of lighting and some other stuff. And so when it's representing 10% of your structure costs, that's something to think about, and it's great potential to possibly reduce some of your costs. Materials also matter in the parking structure. This is not really included in the specification, but I always feel I need to bring it up because too often, as a person who works in the field lighting, people always say, well, how do I get my space to look brighter? What fixture do I use? What light source do you want? And materials matter. I apologize. I may have misspoken on the previous slide. I may have added incorrectly on the slide. I apologize for that. Materials matter in parking structures, and so what I like about these two pictures, one in Natick, Massachusetts, and the other in Tempe, Arizona, they're white. They're using a white ceiling and white columns, and too often the parking structures are left untreated, either painted or bare concrete, and that absorbs the light. And regardless of the technology you're using, the dark surface or untreated surface absorbs light, and that just makes it more of a challenge when you try to do an efficient design. So material matters, and just a kind of a shout out for, hey, let's think about that before we start thinking about the lighting. So possible use of controls. This is an ongoing demonstration the Department of Energy is doing with the Department of Labor. This is great data, so I really wanted to include it. It is just a preliminary data, though. It is the Department of Labor headquarters in Washington, D.C. It's a subterranean parking deck, about 6 floors of parking below the building shown on the right. It is directional flow of traffic, and why that's important is that it affects your use of occupancy sensors. So you can only go, as you enter, you have to go one way. So if you're parking on the 4th level, you have to go all the way down, and you have to leave the same way. And so that affects how the sensors are triggered. It is for an office building, and that becomes really important when you see the usage profile. Originally, the parking structure was lighted with T12s. Then a couple years ago, they replaced it with high-pressure sodium, and then they're testing out a small portion of it with light-emitting diodes. And they use occupancy sensors, and one of the other interesting things is the Department of Energy has another LED program focusing on, it's called Next Generation Luminaires, and this was using one of their products. So what this graph shows is time versus power. So on the bottom of the figure, you're seeing the minute breakdown for the course of a day, and then on the left-hand side you're seeing the current draw, which we can use to roughly estimate what the power usage of the light fixture is. So what we see is that, if you look at the left-hand graph, around 12:01 it spiked, but then from about 12:30 up to about 3 a.m. there's nothing happens. So that means the fixtures are operating in their low state, saving energy. Then at roughly around 3 a.m. or 2:30 a.m., somebody came in, drove by. Maybe it's a security personnel, or maybe it's a person working late nights or early morning, and then the lights went down. So you start seeing the profile, and then all of a sudden there's less, there's no one in the space, so they stay low again. And then all of a sudden, when you start getting into normal operating times for an office building, around 5 a.m. through 10 a.m., you see a lot of high usage. And then you see a kind of in the lull in the mid-morning when most people have already arrived and are at their desks. Then you see a lot of usage again in the afternoon and late hours. And then at about 7 p.m., 8 p.m., you start seeing less people leaving, and then a lull again, and then a spike around 10 o'clock, and that's it. And why that's interesting is it shows you that that by not operating them all the time, there was no one there, essentially, because the sensors didn't trigger. And then this graph contrasts that. So this is a Sunday. I'm sorry, it's a Saturday. And it shows that for the most part, somebody came in. Again, we don't know if it was a person coming to work or if it was a security patrol or what. But around 5:30 or 6 a.m., the lights turned on, then they went down, and then they turned on again around 7:50 to 8 o'clock, and that's it. And so, rather than lighting a space that is completely empty for all that time, the occupancy sensors allowed a fair amount of energy saving. So this slide is a preliminary result so far that we're seeing, that the fixtures are operating in the high state about 30% of the time, and they're operating in the low state almost 70% of the time. There's a number of things that are going to factor into how those happen, one being your timeouts. Right now, the sensors operate in a 10 minutes of timeout, meaning that for once the sensor is triggered until there's movement again, then it actually then it stays on, and then it times out. And so why that's important is that if this fixture, where these fixtures are located, happens to be near the entrance of the garage, and that so if some person's just driving around, as soon as they enter, they trigger it on. So a shorter timeout might actually yield greater energy savings, which is something we're doing, and that's why I'm showing you preliminary data. We're investigating that. The flow of traffic also affects it, as well as the columns are affecting some of the coverage of the fixtures. The picture on the left shows the LED fixture on the left and the high pressure sodium fixture on the right. So then the next part of the presentation moves us into an overview of the CBA specification. I wanted to quickly just touch base on what is a specification. There are different types of specifications. So this specification is more with what we would call a performance-based specification. The idea is that really it's adopted by an end user or a site. So in the example you're going to hear later on, John D'Angelo used it. John D'Angelo working for the Cleveland Clinic used it, and he sent it out to, you could use it, you could ask either a designer or an architect or an engineer to use it and design to it, or you could ask a manufacturer and their application engineer to meet the specification as well. It's pretty direct. It's saying that the product needs to deliver something. In this case, we actually require a certain amount of light measured in foot candles, some uniformity requirements, and then you set it against a unit of energy. In this case, we said watts per square foot, but I know that the National Renewable Energy Laboratory is actually doing some metering, and they're actually setting kilowatt hour because they're trying to incorporate controls. A kilowatt hour is probably a little more is aggressive in terms of energy savings, but it also requires some assumptions and calculations that may not everybody want to do. In contrast, there's what a lot of people are familiar with, which is a technology specification or a product or a widget specification. And those can be done by a request for proposals and mass procurement of the technology. And they can easily be incentivized by energy programs and utilities. It's really easy to say, I give $50 to replace probe star metal halide with pulse star metal halide, or you could do something as such as the Energy Star specification or the CE Premium T8 specification. You could say the product delivers 95 lumens per watt for 95 lumens per watt at mean lumens, such as what the CE similar to the CEE Premium T8 specification does. But that's, again, it's on the technology side. It's not talking about what the light's doing, it's just saying how much light is going somewhere and the power draw, whereas the performance specification is more trying to get a look at the whole system and how much energy is being used by the system. So the first thing that the specification does is it goes for energy conservation, and it sets a power density, which is lighting power density. For those who may not know the term, is total watts installed per square foot in this case, and we set it at 0.18 watts per square foot. When the specification was developed, it was that was probably the lowest. power density being encouraged at that type of level. Recently, I know California, Title 24, they've been looking into possibly reducing their power density to a value near or lower than this value, as well as the ASHRAE 90.1 2010. I believe they're in the 2010 version has reduced it from the previous version to a value similar but not at this level. Why did we pick 0.18 watts per square foot? Well, actually, because it ties into something else that we're going to talk about later on, but I mentioned it here. So in 2005, Congress, they passed what's called EPACT, and part of EPACT has a tax deduction, and I listed it below because the Internal Revenue Service specifically made sure that parking structures were covered under this tax deduction. So the idea is that if you install you can install lighting that is 40% below standard 90.1 2001, you're eligible for the maximum tax deduction. And so that's why we picked that number. So this is another part of the specification, as I said. So we set the power density trying to encourage energy savings, but then we came up with minimum horizontal and vertical lighting requirements. These actually mimic the current version of RP20, which is, for those who may not know the term, RP20. RP is the ISNA's recommended practice, and 20 is their parking structure, parking facilities document. It covers both parking lots and parking garages/structures. So these values mimic those values as well. The only thing that's slightly different is in one case, the committee, and I should have stepped back into this earlier on, the specification was developed by a number of people, as well as it was sent out, and we invited manufacturers to comment on it. We actually did an entire presentation just to manufacturers to solicit comments on it. And so this is not a Department of Energy specification sole project. We actually worked with the Energy Alliances to develop it, so it is really the Energy Alliances specification. And so they wanted better uniformity in covered parking areas, and that's why they required a 7-to-1 max to min uniformity there. They also wanted on the top deck better uniformity, so that's why they went with 10-to-1. A top deck is the top floor of parking structure that's open to the open air. We also require uniformity, another metric of uniformity, which is called the coefficient of variation, which looks at more of the data. Max to min only really looks at 2 points. It looks at your highest point and your lowest point. And in the previous examples I showed, there's columns and other elements. Well, what happens if your minimum point is behind one column and your maximum point is on the far end of the other part of the parking structure? They're still the min and the max, but they're really not almost in context of each other. Whereas the coefficient of variation is a statistical analysis that looks at many of the data points. It's a statistical analysis. All it is the standard of deviation divided by the mean, and so it also it looks at more of the data than just one single point. The specification encourages, actually allows fluorescent, induction, or LED. Again, the idea was that technologies that do not allow for controls easily. That's why it's trying to move away from technologies that can't really be controlled through occupancy sensors or daylight sensors. So it does allow fluorescent, as I said, induction, and LED. These three pictures are from different places. They're not using the specification. I'm just showing them for context. It does require daylight controls within 20 feet of the perimeter if the wall is open to 40%, as well as it requires a reduction in output in the vehicle entry-exit area. Too often, a lot of vehicle entry areas are overlighted during the day, are lighted during the daytime to deal with adaptation from driving into the parking structure during the daytime, so your eye has adequate time to adapt. The problem is that at night, many of those same fixtures are left on so now all of a sudden you're leaving a very bright spot going to a darker area, and so it requires reduction in the entrance area at night. This picture is from a parking structure at a hotel in Cupertino, California, and I just love it because I love it from the point of it shows why it's really important to daylight dim there. It's a full open facade other than some safety grills, and yet the metal halide fixture is on and it's about 10 feet away from the window. It also encourages the use of occupancy sensors. The top picture is a parking structure, is an actual occupancy sensor in a parking structure mounted to a fixture. The bottom one is a fixture in action. This is at a university at Shady Grove in Rockville, Maryland. They use both occupancy sensors and daylight sensors, depending on where the fixture is located, to save energy. Moving into financial incentives, definitely most people are interested in possible ways to ease cost, how to buy it down. And so the next part of the presentation will look at what I mentioned earlier, the EPACT tax credit. The portion of the tax code is called 179D. Also mentioned Desire, which is a website, and then I'll provide some utility and energy efficiency program incentive examples. So financial incentives for LPDs. So as I said earlier, the 179D tax incentive, it provides two different levels. We set ours at the maximum level, which is essentially 60 cents per square foot when lighting is 0.18 watts per square foot for a parking structure. It's applicable to all covered floors, so your floor that's open to the top deck that's open to the open air would not be covered. It was recently extended from expiring in 2009 to December 31st of 2013. Just also mentioned that it's actually allows you to go almost 4 years back as well. So if you've recently installed something in the last 4 years that can meet the requirements of the power density and meets the IES requirements for lighting, you essentially just have to go measure it, and you can write a certification letter, and you can go back. I recommend reading some of the tax language because there's some things you have to do, but it's pretty easy to do from the documentation I've read. Government structures are available for the money, but they have to pass through. They pass the money. So the government agencies are tax exempt, so they can actually pass the money on to a design team through a pass-through mechanism created by the IRS. There's documentation out there that exists to show you how to do it and how it's written. Parking structures are somewhat low-hanging fruit in terms of the tax incentive. The reason is that they're large footprints, but when you think about them, they're actually low equipment density. So you can actually hopefully maximize your tax incentive with a low capital outlay. So here's an example. So when you start talking about tax deduction, many people hear the word credit and deduction and think they're interchangeable, and I'm not a tax lawyer or representative, but they're very different. And so it's really important to know the difference. The key difference is that a deduction is applicable to your tax bracket. So in this example, if I use a parking structure that we had looked at and just picked their area, this is actually a rather small parking structure at 41,400 square feet. So if they had set their power density at 41,400, their power density at 0.18 watts per square foot, you multiply that times the area of 41,000, and then you have to multiply that number again times 0.6 watts. For 60 cents per square foot, and then times your tax bracket, and that's what you get these numbers. So in the end, that's where they would be able to use in terms of their financial incentive. It's a different number, and I don't want people to think that it's a larger number than it is. There's some cautions about the 179D tax incentive. Industry has found that there's low consumer awareness. A recent report estimated by, that was a joint report by NIMA and BOMA, estimated that 82% of building owners did not know about it. It is not applicable to tax-exempt organizations. However, while doing research, I discovered that Senators Bingaman and Snow proposed to allow REITs, which are real estate investment trusts, to be covered under it. That has not gone through, but they are definitely a proposal out there. I would definitely encourage people to contact their legislative members if they're interested in that and trying to encourage those type of proposals. They do exist. There's other modifications proposed by other agencies, and also if you even go look at NIMA's website on this whole topic, they have a list of a number of organizations that encourage increasing the dollars per square foot for it. It is currently extended to December 31st, 2013. And it's not, I say it does require some post-installation documentation and verification. You have to fill out a couple of forms that shows the power density. You actually have to measure some of the lighting in there to show that you've done that and that it deviates within certain standards, because the way it exists is that you still have to meet IES requirements. And then you have to fill out some forms. NIMA has a good website, as well as other agencies have good websites that provide more information. Which brings us to the NIMA website. So this is www.lightingtaxdeduction.org. This is supported by NIMA, and they provide a fair amount of information in here. The screenshot on the right is actually their website, and they include, they have a lot of information in there. They also separate out lighting versus the other mechanical systems that are covered. They also have draft letters in there that you can use, and shows you the type of language that you have to use. They include IRS bulletins because the IRS has made changes here and there to certain parts of it. They also have frequently asked questions and resources. It's a good good resource to use. I go to it and look at it from time to time when I'm wondering about something. This is a tool GE created. I'm not endorsing GE in any way. It's just a tool they created that is worth taking a look at. It is actually specifically a tax deduction eligibility estimator. It's on the screenshot here, and so the first thing you do is you select your building type. They developed theirs for many different building types, but I've of course selected parking garage. You put in different information about what your power density is and what you're proposing to go to, and it does some calculations for you. It also can do some lighting estimates on whether or not your space is meeting it. It is a tool that I would definitely think worth taking a look at, and before you go doing any long-term design. It gives you kind of back-of-the-envelope estimates. It's a good tool, though. The next website is Desire. This is a website supported by the Department of Energy. It is a database of state incentives for renewable energy. This is a website you can click on, so if I live in Texas, you can select it, and it'll bring up a list of all the different incentives. This is not just for lighting. It covers a lot of different technologies, both mechanical and both on the building side as well as on the actual renewable power side. And you can, as well as they also have links to legislative changes and other things like that. It does have some search functions. I don't think the search functions are as granular as putting in parking structure, but it is definitely, if you're looking for either a specific technology or something, it's worth a good place to start. Because the nice thing about these incentives is that the 179D is a federal one, and so you can combine it with a local incentive. Which brings me to this next example. So utilities offer money. So in this case, this is a parking structure in Skokie, Illinois again. ComEd would be their local utility. They offer between $115 and $110, between $15 and $110 per induction fixture, depending on the HID fixture replaced. And then they also offer $100 per ceiling fixture under Smart bi-level option. This came off their parking structure flyer, so that's why I use those values. So in this case, the total incentive money kind of adds up. So if the parking structure was 41,000 square foot, which I showed earlier, and we assumed that they needed 39 fixtures to light the parking structure, they would then, and I'm using examples here, but we picked $50 because it was the middle of the range above. They could get roughly $2,000 from ComEd based on that. But then they can also get the federal tax deduction when you apply the tax bracket, and I picked a number here of 25%. So that's $6,000. So in the end, they get almost $8,000 in incentives, some from the federal level, some from their local level, but it is additive, and that is very nice. Other financial examples. So I tried to touch on, so the specification covers Fluorescent, Induction, and LED, and I tried to show other resources that you could go look at. This one is the Design Lights Consortium. It's a group of many different utilities and energy efficiency programs. This is specifically they have many different programs, but they also have a LED-specific website, so I'm showing that here. They provide, now these are product-specific specifications, so they could actually be used with the Energy Alliance performance specification as well, and has been updated over time, and also allows you to find products that comply with it. And they have a parking structure one, which I zoomed in on. Here, show their current one is, these are the requirements. They require 2,000 lumens. They have a zonal distribution of 20% in the 60 to 70 degree range, and 15% of the distribution needs to be in the 70 to 80 degree range. The fixture efficacy has to be 56 lumens per watt, and so on, and that provides more information. But so I'm really just trying to show you how they all can work together to end at one end goal. But also there is another specification out there, and if you're not familiar with it, this is the CEE commercial lighting fluorescent specification for T8 high performance systems. It's specific only really to the source, not the application. So it doesn't look at the light fixture. It just says, your lamp and ballast combination have to be this efficacious. Again, multiple utilities refer to it. It's I think, a very successful program from what I understand. I think it's the good specification is very good as well. But it's out there, so if people are looking for fluorescent type stuff, it's out there as well. Then I had a hard time finding a nationwide induction program. Many utilities offer incentives for induction fixtures, like ComEd or PG&E or other places, but I've not found a program like either this one I just mentioned by CEE or the Design Lights Consortium that's really trying to promote induction, that is people from across the country participating in it. There is one comment I want to make about induction. So we did encourage the use of bi-level operation through occupancy sensors or dimming. And bi-level induction generators, there are not too many of them made. One thing that some manufacturers use are two lamps. So the fixture has a high wattage lamp and a low wattage lamp, and that's how they do the bi-level operation. But so when you're going down that route, it's there's definitely disadvantages and advantages to each technology. One of them being temperature. Certain sources work better in some places than others. But these are all things to think about. But I just wanted to mention that about induction. Finally, at this point, I'm going to turn the presentation over to John D'Angelo of the Cleveland Clinic, who is going to provide great information on his recent use of specification in a very large parking structure in Cleveland.
Thank you, Michael. I appreciate it. A lot of information. Thank you very much. For those of you who don't know anything about the Cleveland Clinic, it's a fairly large health system that is acuity-based. So we're 203 locations in North America, 13 hospitals, 16 very large family health / ambulatory surgery centers, altogether about 23.2 million square feet and growing about 1 million square foot a year through either new construction or acquisition. Our main campus, which is where this particular project is located, is rated as the highest acuity hospital in the U.S. by Center for Medicare and Medicaid Studies, and consistently top 4 in outcomes and number 1 in cardiovascular for the last 16 years as ranked by U.S. News and World Report. Our main campus is about 50 buildings. That's the whole foreground of the photo that you're looking at about 13 million square feet. The big white circle is the parking garage that is the subject of this presentation. Existing for that parking garage is high pressure sodium, as you can tell by the pretty orange lights. And our desire was really to go to LED. I have honest and open. I have a personal bias against induction lighting for garage based on some discussions with some other Commercial Building Energy Alliance members who have tried them and been dissatisfied. I love fluorescent, but not for open garages in Cleveland. They do suffer some degradation in the winter. Winters have been known to be a little cold in Cleveland. I have a lot of underground garages, and my primary lighting in the underground garages is fluorescent. But for this particular garage, if you remember the previous photo, it's very open. The wind blows through here. It gets pretty chilly in the wintertime, and so we did want to restrict the solution set to LED only. The garage itself is just over 970,000 square feet, about 1,500 spaces. It's 6 stories with an open roof on top. It's divided in half. The north half is for patients and the south for employees. You can see it's about 830 main garage fixtures. The perimeter fixtures are to have photo and motion sensors, whereas the inner fixtures are just to have motion sensors. We wanted to go ahead and change out the entire building, so we did also include the site fixtures on the roof and the stairwell fixtures as part of this RFP. The Commercial Building Energy Alliance specification that Michael had talked about was the basis for our RFP. In fact, one of the nice things I really liked as an owner, I did not hire any A&E firms to package my project. I took the CBEA specification and I modified it for my specific desires. As I've mentioned previously, I redacted the sections on induction and fluorescent so that only the LED sections applied. I added some depreciation conditions. I strengthened some of the warranty provisions. I set the temperature between 4,000 and 5,000 Kelvin, as that's a Cleveland Clinic standard. And I did a little bit of sensor and controls changes to bring that in line with our Cleveland Clinic standards. I also specified some measurement and verification requirements as part of this package with the intent to be able to help shape both the manufacturing industry and us on this call as commercial building owners. I wanted to be able to do some type of a case study for those that are on the fence so that you could show that, through accepted measurement and verification protocols, these are no longer theoretical values. These are the actual values that we're able to achieve. What I did then was I took the specification as the basis of bid, and I used a best value approach for my request for proposal. 51% of the request for proposal was based on price. We have a large program here where we encourage local female-owned and minority-owned businesses. And so that is really part of our mission as a Cleveland Clinic. So 10% of the Best Value Award was set aside to encourage that from the participants. Total system wattage was also 10%. You know, I didn't want first cost to rule. I wanted to incentivize the participants towards a solution that looked at the life cycle costs. Glare and appearance, obviously very important. My patients and my staff are not going to appreciate a solution no matter how much energy it saves or how cheap it costs that drives them nuts when they drive in and out of the garage because of glare or some other appearance function. And then I offered some warranty extension points. So the base in the specification is 5 years, and I offered additional points for every year that a respondent to the RFP wanted to extend that warranty. CRI, the Keller Rendition Index, is important to us because of the size of our campus and the fact that we cover security concerns using cameras, and having a higher CRI allows us to have better visibility with those cameras. With the old high-pressure sodium, you couldn't tell the difference between a black, a dark blue, or a dark green car. Having a good Keller temperature and a good CRI do allow you to do that. And then, as Michael talked previously, we started with the minimum allowable max to min ratio within the specification, and I offered points for contractors that were able to reduce the max to min ratio. And since this was a design build or a turnkey project, essentially, that incentivized the respondents to have to make some design decisions on whether or not to use the existing locations, which may not get them the most max-to-min ratio, but would get them the cheapest price, or whether to change some of those locations, which might cost them a little bit more, but might earn them some additional points on the max-to-min ratio and on the total wattage. So that was the intent, was to have them actually do a little bit of homework in responding to this RFP. The other thing that we did that was definitely different for us, and I think it might have been different for industry, is we invited only lighting manufacturers. So I did not invite contractors, I did not invite distributors, I did not invite engineering firms to bid. It was only the manufacturers, and the prime contracts had to be between Cleveland Clinic and the manufacturers. We had, through a pre-selection program, selected 6 of what I considered to be the top manufacturers in the country to participate. 5 bid, 1 declined. Actually, one of the manufacturers bid 2 different product lines, so we had 6 product lines to go through. It was very competitive. I will be honest that I was very pleasantly surprised at how much work the manufacturers put into their bids. I think I probably learned more in reading their bids than in everything I knew about garage lighting beforehand. I was truly impressed with the level of effort they put into it, and I was extremely impressed with how competitive they priced the project. We had an estimate going in, and they were able to beat that estimate by 28%, which is always a good thing when you're the owner. So the winning bid, and I will tell you that the winning contractor was Phillips Stanco. They were able to garner 78 out of 100 points. I will tell you also that it was incredibly competitive, and my guess is if I choose to go this route again, that they have less than a 50% chance of winning the next one, because the packages that came in were just that competitive from industry. When I ranked the 6 product lines, this one did have the lowest cost at 51% of the total award value. You knew it had to be in the lower quartile for cost. They used the minimum, which was a 3% of their total contract value to an MBE, FBE firms. And when you look at something like garage lighting, where really a large percentage of the cost is in the cost of the luminaires themselves, that 3% is actually a very impressive number. It's actually a very high number. They were second lowest in total system wattage, and they were in the lowest quartile for glare and appearance. They did stay with the standard warranty, which was the 5-year all-in that is specified in the CBEA specification. They were able to bump up the CRI above the minimum, which is in the specification at 70 up to 72, and they were able to really ratchet down the max-to-min ratio to a 3.3. If you remember from Michael's presentation, the minimum in the max-to-min ratio in the specification is 10 to 1. So the existing performance of the garage, as you can see, is just over 1.5 million kilowatt hours per year. The new projected usage is at just under 300,000 kilowatt hours per year. So some of that is sensor-based, but the majority of it is the installed luminaires difference. So the savings of 1.25 million kilowatt hours per year with no incentives at the cost of the contract came out to be about a 4.2-year simple payback. And really a lot of that, my existing fixtures are 190 watts apiece, whereas the new fixtures that Philips are putting in is 72 watts apiece. Now I do qualify for incentives. I don't qualify for the tax incentives that Michael talked about because I am a not-for-profit health system. But Ohio has some very aggressive energy efficiency portfolio standards, and exterior lighting right now is selling at 50 cents a watt. Interior lighting, which I have a very small amount of in the stairwells, is selling at 80 cents a watt. And when you put those savings together, that would change my simple payback from the just over 4 to just under 4 years. So for us right now, our next steps is to continue with the installation, the performance monitoring, measurement, and verification of this project, compile my lessons learned, and revise my RFP and convert my next garage. One of the things I will encourage, and I think the last slide in the presentation after I'm done talking, is next steps as a building owner class, which the majority of the participants in the phone conversation today probably fall into. I think there's 2 really easy things that any owner can do. First and foremost is get involved, and there's 2 great programs that are very easy, and most importantly, they cost absolutely nothing to join. The first is the Commercial Building Energy Alliance, whichever one is most appropriate to your portfolio class. It is a lot of fun and an incredible amount of sharing that occurs. And it's not onerous from a time perspective, and of course, as I mentioned, the cost is free. For those healthcare organizations that may be on, please check us out for Hospital Energy Alliance. Give me a call, send me an email, or just go to the link that I think Linda's going to show you at the end. The other one I would talk about is Energy Star. If you haven't looked at the free opportunities that are available on the EnergyStar.gov website, I truly highly encourage you to do so. There is so much there. Even if you're not interested for whatever reason in becoming an Energy Star partner, what I can tell you is the cost to become an Energy Star partner is nothing but a letter. And we, Cleveland Clinic, have gotten so much out of our partnership with Energy Star that I don't finish any presentation on any topic without putting a plug in for them. The other one, if you hadn't heard about Battle of the Buildings, it's coming out of the Energy Star program. It's the second year of the National Building Competition. I highly encourage you to do some Google search on it. There are more portfolio types this year than there were last year in the inaugural National Building Competition, and there is some lessons learned there for all of us as building class owners. And that's really all I have, and I'm assuming, Linda, that you're going to take control.
I'd just like to thank everyone for participating today and thank our speakers once again.